Today, you're going to learn how to unlock your potential for AP Physics. You don't want all of your hard work to end up in that dreaded 1 or 2. But I got some good news for you. I got you covered with some of the best strategies out there. As an 18th year physics teacher and former AP Physics student, these are strategies that I've taught, used, and created to help thousands of people in person and online. In my opinion, there's two main issues. Either one, people don't actually know the best strategies out there, or two, here's the big one, you know the best strategies, but you don't actually use them. So I'm here to help you today and unleash a side of you that you've never seen before. Strong content knowledge will definitely score you some points, but pairing these with the best strategies and mindset techniques are sure to take you to another level. Stay tuned for the entirety of this video to learn these strategies, see them in action, and also how to customize these strategies to be as effective as possible for you. On the screen, we have all of our multiple choice strategies. You may want to screenshot them, write them down, or there's a link in the description with a document where you'll see all these on the third page. Now, in blue is step 1 of our process, which is pacing. Step 2, we're going to show all the strategies in action with a couple sample problems. And then step 3, we're going to show an example blueprint of how to implement these strategies into your practice. All right, here we go. Everyone knows that they need to pace themselves, but how do you keep yourself from nervously checking the time every few minutes? We're about to find out. You're looking at 80 minutes to complete 40 multiple choice questions, 2 minutes per question. Here's how to effectively pace yourself without breaking your focus too often. As you're taking the test, check the time in 10 question increments. Here's an example of what this might look like. If you're a bit behind, then you want to step up your pace a bit while remaining calm and focused. Taking a deep breath, breathe out slowly, and keep it moving. Now let's go ahead and work out 2 example problems to see these strategies in action. One's an AP Physics 1 problem and one's an AP Physics 2 problem. The content really doesn't matter. It's more about the approach. All right, so I got 3 graphs here, and it says the graphs above represent position x, velocity v, and acceleration a as a function of time t for a marble moving in one dimension. Which of the following could describe the motion of the marble? All right. Normally, I would recommend reading the problem twice, but there's obviously not too much to break down there. So reading it once would be fine. Now, I'm not going to look at the answer choices, and I'm going to want to develop my idea and draw out things and use formulas if necessary. And for this one, I'm just going to take a look at my graphs here, and they're all representing the marble. I'm going to go with the velocity graph because that's the one I'm most comfortable with. So if I'm taking a look at the velocity graph, I have something negative moving towards 0. So it's going in the negative direction and it is slowing down. And then if I take a look at the positive end here, it's now moving in the positive direction. It's moving away from 0. So that means it is speeding up. And then one thing that I notice is this slope is constant, which means the acceleration is constant. So the acceleration is constant. Okay, so I think I broke down all the concepts I needed to before I jumped into the answer choices too quickly. All right, so we got A, rolling along the floor and then bouncing off the wall. If it's rolling along the floor, that would mean it is moving at a constant velocity, so I don't like that choice. I'm going to slash out A. Rolling down one side of the bowl and then rolling up the other side. So if I'm picturing a bowl, it's sort of rounded, okay? If it's rounded, the acceleration does not seem like it's going to be constant, so I don't like that choice either. Rolling up a ramp and then back down. Okay, so that could mean doing one of two things, going up and down this way or up and down this way, depending on what the ramp looks like. I'm trying to match this idea up with what they have. So, can you move negative and then slow down? That does seem like it could be the case. And then once it comes back down, would it be positive and then speeding up? So, yes, I do definitely like that choice. But then I'm going to go ahead and read D, falling and then bouncing elastically off the floor. Okay, falling down would be negative, but it'd be speeding up, so I don't like that choice. So I'm definitely going to go with C. After I finish the problem, I would typically reread the question to see if it really matches up nicely with the answer that I came up with. Again, this one doesn't go in too deep with any physics concepts. So as soon as you figure out it's C, I would just go ahead and move on from there. For our next question, the figure above shows three resistors connected in a circuit with a battery. Which of the following correctly ranks the energy dissipated in the three resistors during a given time interval? Okay, now when I'm reading energy dissipated, I'm definitely thinking about power because that's the change in energy or work per time. So I'm already starting to take a look at formulas. Remember, formulas are not just for number crunching, they're for a lot of conceptual stuff too. So I know that power equals IV, and I also know that V over R equals I, okay, or delta V. So if I go ahead and say that V equals I times R, I can do a bit of a substitution that I've done many times before. And then I can also say P equals I squared times R. Okay, so that's all running through my head fairly quickly. If I glance at these, I'm just trying to rank them. So the choices, I don't even really need to look at them right now because they all are going to be variations of different kinds of rankings. All right, so I'm thinking about what's happening with the current here. We have one branch that has 400 ohms total and one branch that has 200 ohms total. Okay, I do like that because I have one branch that has 400 ohms and then one branch that has 200 ohms. So there's a nice little relationship there, which shows me that if I have double the resistance, I'm going to have half the current. So I'm going to say that this is a current of 1A and this is a current of 2A because if it's half the resistance, it's going to be double the current in that branch. All right, so now I'm thinking the I is going to be a major component in affecting the amount of power. So if this is double, then we have something like 2 squared, which is 4. 4 times 200 is something like 800 watts. Okay. And then over here, this 400 is actually a 100 and 300 ohm resistor. Okay, now both of those are getting the same current, but this one clearly has a bigger R value. So my ranking that I'm going to put down in my head is going to be 1, 2, and then 3. And then I'm going to look for something that matches. So this one says the 300 is first. Okay, that choice I don't like already. This one says the 300 first. That one I don't like already. So the last two I see, they have 200. Okay, so I'm already focused on C and D for sure. This one has 200, 300, and 100. I do like that choice. I'm almost 100% sure I'm going to pick that. And this one says 200, 100, and 300. Okay, so that didn't throw in any kind of solution there that maybe changed my mind. So I definitely like C again. Okay. Very quickly, I am going to reread this one to make sure I went about it the right way. We have three resistors. Which of the following correctly ranks energy dissipated in the three resistors during a given time interval? Okay, so I feel like the idea that I used did correctly match what they were asking for. So I'm happy with that one and I can move on. So I did a bunch of different things. I used the process of elimination. I read the question a couple times just to make sure I was clear on it and did a bit of a double check. I produced my solution and used formulas for ideas and concepts. And I came up with my concepts and ideas first before I had my mind change, maybe by some solutions. And then I went ahead and found my solution and I matched it up with the ideas I came up with already. As mentioned earlier in the video, knowing strategies but not actually executing them is useless. So what you want to do is make sure you come up with a plan of implementation to slowly incorporate these strategies into your practice. Here's an example of what that might look like. Now you're equipped to crush the multiple choice section, but that's not going to mean a whole lot if you get stumped on the FRQs. In my opinion, the free response strategies are much more significant than the multiple choice strategies. The reason being is because you will very likely work these questions out of order and skip some sections. So let's learn how you can rack up the most amount of points possible on these FRQs. For the free response section, we're going to hit it in a 3-step process, similarly to what we did with the multiple choice strategies. We're going to talk about all of the overall approach strategies and the additional ones that are to be implemented with each problem. From there, we're going to go ahead and see those in practice as I move through an entire free response test to make sure I take them in order of difficulty, and then we'll focus in on one specific problem to see how we're going to approach that with these strategies. Okay, what we're going to do is we're going to skim the questions and rank them as E, M, and H for easy, medium, and hard. Some people say that you should rank them in order of difficulty as in 1, 2, 3, 4. I'm going to actually show you a hybrid version of those two strategies that I actually think is the best, and then you pick the version that you think suits you. Next, we're going to take a look at these additional strategies. These are how you attack each of the individual questions. We're going to be aware of the suggested times, circle some task verbs, practice our organization, make sure we X out anything as opposed to spending a ton of time erasing it thoroughly, and then skip certain subsections if they look particularly difficult, and then just keep it moving from there. So without further ado, let's go ahead and check out the 2024 AP Physics 1 free response test. Regardless if you're taking AP Physics 1, AP Physics 2, or AP Physics C, the examples I'm going to show you are more to show the strategies. It's not really based on the content. So if you're thinking to yourself, I'm not even taking the AP Physics 1 test, it really doesn't matter because you're going to learn the strategies either way. All right, so let's go ahead and check these out. I'm just going to scroll through 4 of the questions, and then I'll kind of talk through my thought process. So I'm taking a look at question 1. I see a mass going down a hill, going around a couple loops. Everything is in terms of some R's. So far, I like this question because it seems like a similar scenario to some problems I've seen before. Okay, let's keep on moving. Go on to the next page. It asks for some energy bar graphs and then some conservation of energy stuff. All right, so I'm going to go back to the beginning of the question over here. And so far, I do like that question. So I'm going to go ahead and write E for easy. I'm going to go to my next question, question number 2, and it has some springs and some masses, okay? Now, I wouldn't jump to conclusions too quickly because there are some pretty simple labs, such as hanging masses from springs and just finding a K value with some different masses. I'm going to make sure I do a little bit of scanning here. So we're hanging springs, the K, unknown spring constant K. Okay, so it does sound sort of similar. And then in addition, the student has access only to a variety of cylinders of unknown masses, a stopwatch, and a digital scale. Okay, so far when I'm hearing those things, I don't like those options, but let's go ahead and take a peek at the next page. Just regular experimental design stuff, finding K values, and then that's the next question already. All right, so I'm going to go back to this one, and I'm going to go ahead and call this H for hard because at this point, I don't have like a really clear path of how I'm going to solve that, and it's going to take a little bit of extra thought. Okay, so I'm going to call that H for hard, which may be the last question I get to. All right, let's go ahead and check out our next question. Question number 3. Again, sort of looks like something I've seen before. There's a beam, there's a string. Let's go ahead and see there's a uniform beam connected to a hinge. Following the rectangle, draw and label forces. That sounds like something I could probably do. I'm fairly comfortable with that so far. And then the string is attached to the wall, some comparison of forces, some derivation with some variables. And then over here, we have something where the string is cut and then something with angular speed. That sounds like it's going to be a little bit on the tricky side. Okay, so the beginning part seemed like something that I was fairly comfortable with, and they had some difficult questions as we went along. So I'm going to call that M for medium. All right, let's go ahead and move to the next one. The next question over here has some block sliding. So far, it looks like something that I'm pretty familiar with, just some blocks moving. It looks like they're probably going to collide. We have block B, it's initially at rest. They collide elastically and then determine the speed. Okay, that doesn't look too bad. And then this one over here, it now has a position versus time graph. Here's block B, that's still A, that's moving, something with center of mass. Draw and label some stuff on the graph, justify, and then I think that is the end of the exam. All right. So based on what I saw for the beginning part of that problem, looked more on the easy-ish side. Drawing the graphs sounded like something that might be a little time consuming. So I'm just going to go ahead and call this one medium. Okay, so like I mentioned before, if you're able to rank them 1, 2, 3, 4 easily, I would say that's the route for you, because then you know the exact order in which to attack the problems. Now, for me, I'm actually really close to knowing the order because I had one easy, one hard, and two medium. So obviously, I'm going to do the easy one first, and then I have the medium ones in the middle, and then I have the hard one last. So my hybrid method is this. So since I have two mediums, I had a medium right over here, which looked to be like easy, and then the next page seemed to be like maybe a little bit more difficult or time consuming. And then taking it back to the other one, this one looked to be medium, but then there was some stuff again towards the end of the problem over here, which I thought might be a little bit tricky. Okay. To me, it looked like the very last problem I looked at was probably a little bit easier. So I'm going to call this my medium question that I'm going to hit second. And then this is the medium question I'm going to hit first. Okay. Now I know my order. Okay. So quick recap. I did like this question because of my familiarity with that topic. So definitely going to do that one first. And then I'm going to jump to my mediums. My medium that I wanted to do first was this block question because I liked that one. I was a little bit more comfortable with it. Then I'm going to slide back to my other medium question. Again, that one I felt pretty good about, but there were some hard ones sort of towards the end. And then lastly, I'm going to go to my experimental design one. That one seemed to be a bit tricky, so I'm going to hit that one last. That way, you're going to rack up the most points possible, doing it in that order. That is probably, if not for sure, your number one strategy for hitting the free response section, going from the easiest to the hardest question. Okay, the thing is, although that is a very significant strategy to implement, you don't want to spend too much time. Okay, so since I was narrating, I did it a bit slower, but I want to do all that in my head, and I would say roughly 1 to 2 minutes if possible. Okay, obviously, the shorter the better. Okay, now let's go ahead and focus in on one question. All right, so focusing in on this question, I have my little piece of paper here, which is kind of like my fake booklet, and then my full question over here. Okay, again, the focus is not the content, it's more of the mindset, the approach, and the strategy. All right, so we have a block that slides along a horizontal surface towards B, which is initially at rest. The initial velocity equals 0 for this one, and then this one has some kind of non-zero velocity to start off with. The masses blocks A and B are 6 and 2 kilograms respectively. Those are already labeled. The blocks collide elastically at t equals 1 second. As a result, the magnitude of the change in kinetic energy of block B is 9 joules. Okay, so I know a few things. I know that I'm going to use some conservation of energy stuff. It said elastically, so I'm going to say my K final equals my K initial. And then also, I don't really see how it connects at this point, but we'll say conservation of momentum is probably going to come into play somewhere around here. All right, so I don't know if I'm going to score any points for those sorts of things, but if I'm thinking and spending 5 or 10 seconds to write these little things, the potential of them scoring me points is definitely worth the 10 seconds of writing down that little bit of scratch work. Now, as you can see, my handwriting is not the best. I am not the neatest, most organized person. So I'm really thinking about how to lay out my information and not make it all scrambled for my own organization mentally and physically on the paper, and then also for people to grade as well. So now really getting a little bit deeper into the problem, we got a couple things going on. It says determine the speed of block B. Okay. So you're not going to be able to necessarily circle it on the computer, but I'm just going to circle it for you and they bolded it. So this one doesn't seem too bad. Determine the speed. If the kinetic energy is conserved, then this one has a delta K of 9 joules, and then looks like this one then would have a delta K of negative 9 joules. So I'm looking for the speed of block B. So to keep my organization going, block B, speed, question mark. Okay, again, it looks like a lot of writing, but it's some very quick little things I'm jotting down as I'm thinking. So it goes from 0 to 9 joules of energy. Obviously, when it has 0 joules of energy, it's not moving at all. So we have 9 joules equal to 1/2 m v squared. Okay, 1/2 times 2 is 1, square root both sides, and then we're done. Okay, that was a particularly simple EP FRQ question. Like I said, the point was not the conceptual angle of it, it's more of the strategy. All right, so I thought about all of the main ideas, I jotted them down as I went along. I labeled stuff, I kept my thoughts organized. I tried to physically organize my work so it's clear for me to see and it's clear for the graders to see as well. I tried to pull in any pertinent equations. It didn't look like I had to pull in any like mass time velocity or anything like that. Looks like I just needed that 1/2 mv squared. So that's it for the approach for this problem. Now let's go ahead and take a look of how you might do a little bit of skipping within a question. All right, so we just completed my medium one question. So technically it would have been the second question that I would have been answering. And then that one would have been checked off. I would have been feeling pretty good about it. And then moving to the next part. On the graph in figure 2, draw and label 3 lines to represent the positions of block A, block B, and the center of mass of the 2-block system as functions of t between 1 and 2 seconds. Each line should be distinctly labeled. All right. Now I feel pretty decent about that question. Now the center of mass part kind of like threw me for a little twist. So I'm kind of getting a little jumbled there, and I am not thinking clearly, and I'm having trouble even starting part B. So here is a strategy that you're going to implement that is, I would say, probably the second most important strategy besides doing your overall ranking. So part B, I'm like, oh my gosh, I'm having a bit of a blank question mark. I think I'm going to come back to that one. That does not necessarily mean that I can't do part C. Okay, so you want to make sure if you don't know part B, you can possibly go to part C. If you don't know part B and C, you could possibly go to part D. Okay, now it says consider in the original scenario, instead of colliding elastically, the blocks collide and are stuck together. Okay, so I'm thinking inelastic right away. Describe how the line drawn from the center of mass in part B would change. So there's some sort of center of mass line that I would have been drawing on the graph if I had done B. Briefly justify your response. So far what I'm thinking is that it's definitely going to be something that is inelastic. And I'm also thinking that the center of mass should stay about the same, whether it's elastic or inelastic. Okay, that's just my gut. Okay, so I'm going to go ahead and say the line drawn from part B would be the same. And then I'll say in an inelastic collision, momentum is conserved. but energy is not. Okay, so if I'm thinking kind of quickly and feeling a little bit less confident because I didn't do B. If I would have done B completely, I would have been feeling a little bit stronger about C. Okay, but I ran into a bit of a mental block, skip B, jumped to C, and just kind of wrote what I thought that would maybe help me justify. Okay, so I read the question, pulled out the concepts that I thought would be pertinent. I was thinking that it would be the same. Inelastic collision, momentum is conserved, energy is not. Okay, that seems like an incomplete answer to me, but as far as I know, those seem like things that I'm pretty confident about, so I just went ahead and wrote them down. All right, so now when I'm taking a look at the AP scoring guidelines, now actually, I didn't know what the scoring guidelines looked like. I actually pulled them up afterwards, and I was pleasantly surprised that I scored all the points. So it says for indicating the line drawn from the center of mass of the two block system is the same, and then also saying the explanation indicates one of the following: momentum is conserved and no external forces on the two block system. Okay, so I did get one of those. So that means I scored both of those points. So although my explanation felt a bit incomplete, I skipped B, went to C, and then racked up those 2 points for C. So that is a huge strategy that you definitely want to implement. Now, lastly, what I'm going to do is go ahead and show you an example blueprint of how to implement these things into your practice. There you have it, the strategies and the blueprint to unlock your best score. There's a link in the description to help prep you for the AP Physics 1 exam with a bunch of links and other resources. On the third page of the document, all of the strategies we just discussed are on that third page. So AP Physics 2 and AP Physics C students, definitely go and check that out as well. Please share this with your friends and classmates so they too can unleash. Please consider liking, commenting, or subscribing if you found some value in this video. Good luck.